Wind power. We need to outline the basic features of a wind generator. Sometimes it's called a windmill. It is not a windmill. It is not used to make flour. We also need to determine the power that may be delivered by a wind generator. We have to derive the formula, and assuming that the wind kinetic energy is completely converted into mechanical kinetic energy, and explain why this is possible. I think this should say explain why this is not possible. So how do wind turbines work? Well, we have wind, which is kinetic energy. It drives the blades round, which is connected to a turbine which spins round, kinetic energy, and this is connected to a generator which runs a generator which provides electrical energy. They're considered clean energy because they do not produce any polluting waste, no carbon dioxide, no greenhouse gases. Some people believe that this is an eyesore or ugly, and some people say it is rather noisy, so some people object to them. And it's said that they can kill migrating birds, and especially bats. This is from a website from 2008. There are lots of stories of dead bats being found at the foot of these wind turbines, and it was rather strange because it was clear that the bats had not been struck by the wind turbines, but nevertheless they were dead, and blood was seen coming from their mouths. The reason for this is that bats are not birds, they're mammals, and they do not have the same breathing system that a bird has. The lungs are weaker than that of a bird. So what happened is that as the blade would be moving round, there would be a sudden change in pressure, and this change in pressure was too much for the lungs of the bats, so that basically their lungs ruptured and they died. So why are wind farms built? Well, here we have a wind turbine. This wind farm can produce 10 megawatts, which is enough for 6,000 homes, and it basically reduces the carbon emissions by around 24,000 tons of carbon dioxide per year. And here's another one, which is 3.6 megawatts, which is an offshore wind facility. So we have to determine the power that may be delivered by a wind generator, assuming that all the kinetic energy of the wind is going into the electrical energy produced by the generator. We have to be able to know this derivation. So we have a volume of air moving across the blades of the wind generator. It has a length according to the speed, which is going to speed times time, and we have an area. So what is the volume of the moving air? Well, it's obviously going to be A times by X, the area, times by the length of a cylinder, but the X is equal to Vt. So the volume is equal to A, which is the area covered by the blades, times by V delta T. Now we need to know the mass of the air that's flowing past. We know that the density of the air is mass divided by volume. So the mass of the volume, the mass of the air, is going to be rho times by volume. We know that the volume is A V delta T, so it's going to be rho times A V delta T. Now we need to know the kinetic energy of the air. The kinetic energy is half mv squared. We know the mass that's changing per second, so it's going to be half m, where m is rho A V delta T, times by v squared. And we can simplify a little bit by having the v times by v squared to be v cubed. Then we divide by t. So it gives us basically the change in the kinetic energy that's been able to be delivered to the wind turbine is equal to half rho A v cubed. So this is the energy delivered per second. Now this is if all the kinetic energy of the wind is converted to electricity. This is the power that will be produced. However, wind turbines are only 35 to 45% efficient. How can we increase the power? Well, we can increase the power by increasing any of these factors here, by having a high velocity. That changes the power by a great deal. If you double the velocity, v cubed is going to be 2 to the power of 3, so you will get 8 times as much power. Another thing, if you have an area, if you double the area, you're able to produce twice as much power. Remember that the area, is pi r squared, where r is the radius of the circle, in other words the length of the blade. Now we know that these are not going to be 100% efficient, and some energy is going to be lost also in the friction of the parts, also in the resistive heating of the wires, and also you have to remember that not all the kinetic energy of the wind is going to be given to the turbine, because it would mean that the wind would have to stop as it passed through the turbine.